Hi, welcome to this series of videos on preparation for your GMAT quantitative reasoning section. The GMAT is scored on scale of 800, out of which the weightage of your quantitative reasoning is half of that, and one of our topics that we will be covering today is factors. Let's begin. Let's look at the first question now. A and B are positive integers less than or equal to 9 if A and B are assembled into a 6-digit number A, B, AB, AB, which of the following must be a factor of AB, AB, AB. Okay. So, for the number to be a factor, we have some factor rules. For 3, it is when the sum of the digits are divisible by 3, then it is definitely divisible by, the number is divisible by 3. Sum of digits will be equal to, when you look at this number, will be A plus B plus A plus B plus A plus B, which is equals to 3A plus 3B. So, this is equals to 3 into A plus B. The sum of the digits is definitely divisible by 3, therefore, the number will also be divisible by 3. So, the answer is option A. We have other divisibility rules to check for that, like if you have to check for option B whether this number is divisible by 4, you have to know whether or not the last 2 digits are divisible by 4. The last 2 digits are nothing but A, B, but we are only given that they are positive integers less than or equal to 9, but we are not told anything else about the 2 digits. So, we cannot comment at all whether or not it is divisible by 4. Similarly, for 5 and 6, you can check the divisibility rules, and you will see that it is neither divisible by 5 nor divisible by 6. So, 3 is our answer. Answer is option A. Let us look at the next question now. If A and B are integers and 2 to the power of A into 3 to the power of B is a factor of 100 to the power of 40, what is the largest possible value of AB? Okay. So, they are saying that 2 to the power of A into 3 to the power of B is a factor of 100 to the power of 5. So, this will be into some constant k will be equal to 100 to the power of 40. So, we know 100 is nothing but 4 into 25, which is 4 is nothing but 2 square, and 25 is nothing but 5 square. It's that whole raised to the power of 40. So, this is equals to 2 to the power of 2 into 40, that is 80, into 5 to the power of 80. So, 2 to the power of A into 3 to the power of B into k, some constant k, will be equal to this. And when you look at the right hand side, there is no 3 to the power of anything. There is, you can say that it is into 1, and you can express this as 2 to the power of 80 into 5 to the power of 80 into 3 to the power of 0. So, this is the only possibility when you are equating the powers on both sides. You can say that naturally be equal to 0. Therefore, the value for AB will be equal to 0. Does not matter what the value of A is. We did not even have to solve so much. When you just directly look at 100 to the power of 40, you can just say that there will be no 3 in it. So, 3 has to be raised to the power of 0. So, hence B is 0. So, whatever A is, AB is equals to 0. Answer is option A. That is a quick way of solving without actually solving the values. Now, let us look at the next question. If n plus 12 whole square is divisible by n, where n is a natural number, how many values can n take? Okay. N plus 12 whole square is divisible by n. So, n plus 12 whole square is what? Let us expand it. It is n square plus 12 2s are 24 into n plus 144. So, n out of when this is divisible by n, what we are noticing is n square is definitely divisible by n, and 24n is also divisible by n. So, the only number that is left is 144. Hence, 144 should also be divisible by n, since the sum of these 3 numbers is divisible by n and these 2 numbers are divisible by n. The third number also should be divisible by n. Therefore, 144 must be divisible by n. That is 144 is equals to some k into n. 144 is nothing but 12 square, which is 4 into 3, that is 2 square into 3 whole square, which is equals to 2 to the power of 4 into 3 square. So, for checking how many values can n take, so n is a factor of 2 to the power of 4 into 3 square, that is 144. So, the number of factors of any, you need to know this equation, for any number n is equals to x to the power of a into y to the power of b into z to the power of c. The number of factors formula is given by a plus 1 into b plus 1 into c plus 1, where a, b, c are non-negative, a, b, c are integers. So, number of factors for 144 will be 2 to the power of 4 into 3 square, where x, y, z will all be prime numbers. Here x, y, z should always be prime numbers, and a, b, c will be the exponents. So, the number of factors will be 4 plus 1 into 2 plus 1, that is equals to 5 into 3, it is equals to 15. So, n can take 15 different values, that is answer is option D. Let us look at the next question now. The greatest common factor of positive integers m and n is 12. What is the greatest common factor of 2m square, 2n square? Okay, so when these 12 is a factor of m, you can say that m is equals to 12 into some constant k1, and 12 is also a factor of n. So, 12, it is a common factor of both m and n. So, n is also 12 into some constant k2. So, they are asking us what is the common factor for 2m square and 2n square. So, m square will be equal to, squaring on both sides, it will be equal to 144 into constant square, and n square will be 144 into constant square. Now, you have 2m square which will be equals to 288 into k1 square, and n square 2n square will be equals to 288 into k2 square. So, when you look at these two numbers, what do you observe? They have a common factor of 288, and it is k1 and k2 do not have any other numbers in common, no factors in common, because we were given that 12 is the greatest common factor of m and n. So, therefore, 12 into k1 is separate, 12 into k2 is separate. Therefore, the greatest common factor of 2m square and 2n square will be equals to 288, which is option E. Answer is option E. Let us look at the next question now. If n plus 12 is a positive odd integer, which of the following must be true about the sum of the next 4 integers? Okay. So, n plus 12 is an odd integer. So, they are asking us sum of the next 4 integers. The next 4 integers will be n plus 13, n plus 14, n plus 15 and n plus 16. Since n plus 12 is odd, n plus 13 will be even, n plus 14 will again be odd, then this will be even and this will be odd. So, when you noticed, when you add these numbers, they are asking the sum of these 4 numbers. Okay, when you will notice that even plus odd is equals to odd, plus even plus odd is again equals to odd, and then now odd plus odd is equals to even. Therefore, this sum is even. So, when sum is even, the number is always divisible by 2. Therefore, answer is option E. Answer, it is always a multiple of 2. Sum is even, you cannot say that it is divisible by 4, it could be or it could not be, and if you check for the sum of the digits, we do not know anything about the digits. So, we cannot comment on whether it is a multiple of 3 or multiple of 5, but we can definitely say since the sum is even, then it is divisible by 2. Let us look at the next question now. If a and b are both factors of 50, which of the following must be true? AB is greater than or equal to 2. So, here we can do by checking the choices. If you take A is equals to 1 and B is equals to 1, they have not said that A and B are different or that they cannot be alike. So 1 is also a factor of 50 and 1 is also a factor of 50. So B, when A and B is equals to 1, the product of AB will be equal to 1, which is less than 2, but when A is equals to say 5 and B is equals to 1, then AB will be equals to 5, which is greater than 2. So you cannot definitely comment whether AB will be greater than 2. So this option is out. A plus B is less than 50. Again, if A is equals to 1, B is equals to 1, then A plus B is equals to 2, which is yes, less than 50. But if you take A is equals to 50 and B is equals to say 1, you will have the sum A plus B is equals to 51, which is greater than 50, because 50 is a factor of 50 definitely. So 50 or it can be 1. So the sum will come out to be greater than 50. So you can definitely not say that for sure that A plus B is less than 50. AB is a factor of 100. So the product AB is a factor of 100. If say A is 1 and B is 5, you will say yes, AB is 5, it is a factor of 100. But if you take A is equals to 25 and B is equals to 5, 25 into 5 is 125, it is not a factor of 100. Okay. Now when you look at this option D, A is equals to, A is a factor of 50. So we can write A is K into some constant K1 into A is equals to 50 and some constant K2 into B is equals to 50. Now when you are talking about AB, you can multiply these both. You can say K1 into K2 into A into B is equals to 2500. So definitely AB is a factor of 2500. So answer is option D, where AB is a factor of 2500. K1 into K2 will be some constant, and hence AB, product of AB will definitely be a factor of 2500. We cannot again comment whether AB is even or not. So that option is also out. Let's look at the next question now. How many positive integers less than 250 are a multiple of 4 but not multiple of 6? Okay. So to check how many multiples of 4 are there, you will take the number that is integer which is given 250, the positive integers less than 250 that are multiplied by 4, divide 250 by 4, you will get 4 6 are 24, 4 2s are 8 plus 20 plus 2 by 4. So 62, there are 62 numbers, there are 4 into 1, 4 into 2, so on, 4 into 3, so on up to 4 into 62 will be your numbers which are less than 250 and are divisible by 4, which are less than equal to 250 and divisible by 4. Similarly, when you check for the multiples of 6, you can check for the multiples of 6, but out of these numbers you are checking whether a number is multiple of 6. There are 62 numbers here. It should not be a multiple of 6. That means it should not be a multiple of the LCM of 4, 6. What is the LCM of 4, 6? It is 12. So you will have to check the numbers which are not divisible by 12. Again you will have to check 250 divided by 12, which is equals to 12 2s are 24, 25, 12 zeros are plus 10 by 12. There are 12 into 1, 12 into 2, there are 20 such possibilities where the number is divisible by both 4 and 6. So these are 62, out of which you will have to remove 20 numbers which are divisible by 12, that is LCM of 4, 6, that is divisible by both 4 and 6. Hence, we have the total number of positive integers that are a multiple of 4, that means minus multiples of 12, which is 62 minus 20, that is equals to 42. So basically what we did was to eliminate the numbers which are a multiple of 4 but not a multiple of 6, you will have to check the numbers which are multiple of both 4 and 6 first, that is LCM of multiples of LCM of 4 and 6, that is 12, and you will have to eliminate them. You will have to subtract them from all multiples of 4. You have 62 minus 20 is equals to 42. Answer is option C. Let's look at the next question now. Among integers from 1 to 50 inclusively, what is the number of multiples of 4 or 5? Okay. So, as we had seen, to check how many multiples are there of 4, let us just check 1 to 50. In 1 to 50, you need to divide 50 by 4, that then you will get 4 ones are 4, 5, 4 twos are 8 plus 2 by 4. This is a reminder. So, you have, therefore, you have the number of multiples of 4 will be equal to 12. Similarly, for the number of multiples, this was for 4, and when you are checking for 5, it needs to be a multiple of 4 or 5. So, when you check for 5 in 1 to 50, when you divide 50 by 5, you have 50 divided by 5 is 10 plus 0 by 5. Therefore, number of multiples of 5 is 10. Here you have 12, here you have 10. Yeah, since it has to be a multiple of 4 or 5, you can just add these two numbers. But when you are adding these two numbers, you were checking you need to check the numbers that are divisible by both 4 and 5, because they will be counted twice. They will be counted both in these 12 as well as in these 10. Like say for suppose 20 is counted in both multiples of 4 and it is counted in multiples of 5. So, for checking what the multiples of 4 into 5 are from 1 to 50, first you will check the LCM of 4 and 5. 4 and 5 is nothing but 20. Therefore, you will divide 50 by the LCM, that is 20. If it is divisible by both 4 and 5, it is definitely divisible by the LCM, that is 20. So, 50 divided by 20 is nothing but 20 twos are 40 plus 10 by 20. Therefore, there are the number of multiples of both 4 and 5 is equals to 2. Therefore, now you can say that the number of multiples numbers that are multiples of 4 or 5 will be equal to 12 plus 10 minus 2, because the numbers which are counted twice, which is multiple of LCM of 4 and 5, that is 20, will have to be removed once, because we need to count each number only once. So, 12 plus 10 minus 2 will be equals to 10 plus 10, that is 20. There are 20 numbers between 1 to 50 which are multiples of 4 or 5. The answer is option D. I hope that was clear. First we calculated how many multiples of 4 are there between 1 and 50, and we calculated how many numbers or multiples of 5 are there in between 1 and 50, and then we calculated what are the number of multiples of both 4 and 5, since they have been counted twice between 1 and 50, and we just subtracted it once. So, to get our answer 20. Now, let us look at the next question. How many positive even integers are factors of 72 to the power of 3? So, we are given the number 72 to the power of 3. 72 is what? 72 is equals to 8 into 9. 8 into 9 whole to the power of 3. So, 8 is what? 8 is 2 cube and 9 is 3 square. This whole to the power of 3 will be equal to 2 to the power of 3 whole to the power of 3 is nothing but 2 to the power of 3 into 3, that is 9, and 3 to the power of 2 into 3 to the whole to the power of 3 will be 3 to the power of 2 into 3, that is 6. Now, to find the number of factors, I have already said, when you are finding the number of factors of x is x to the power of a into y to the power of b into z to the power of c, you will write a plus 1 into b plus 1 into c plus 1. And if it is there is another number, if they keep adding m to the power of say d, you will add d plus 1. This goes on. This is a standard form of how to calculate the number of factors, where x, y, z, m, all these numbers are prime, and A, B, C, D are their exponents. Okay. So, now we are asked, we need all the even integers that are factors, we need the even factors, we do not need the odd factors. If you see 2 to the power of 9 into 3 to the power of 6, 72 to the power of 3 is equals to this. So, the total number of factors will be 9 plus 1 into 6 plus 1, that is 10 into 7 is equals to 70. But from this we want only even factors. So, let us subtract the odd factors. When will the factors be odd? When we are checking only the for 3 raised to 6, we are excluding all numbers which have any power of 2. So, we are excluding 2 completely. So, for it to be odd, the total number of factors, odd factors will be equals to 6 plus 1, that is equals to 7. Therefore, so the total even factors will come out to be total factors, that is 70, minus total odd factors, that is equals to 7. It is equal to 63, which is option D. So, hope you understood that. We calculated the total factors, total number of factors, from which we subtracted the total number of odd factors to calculate how many even factors does the number have. So, those were some questions on the topic of factors. Hope they were clear. Thanks for watching.